Hello everyone. So last time we talked about outliers and one method which was isolation forest that helped us to remove outliers from the data set and then compare the original data set with the reduced data set using mean absolute error, right? So there are four different methods that I'm going to talk about. One, actually, isolation forest, I already talked about, which is a kind of decision tree based on decision tree algorithm. And what it does, it is based on modeling the normal data in a way to kind of isolate abnormalities that is based on quantity, based on characteristic of the observation. So it will choose the outlier based on different characteristics and also quantities. And then the other method that I'm going to talk about today is minimum covariance determinant, which is a kind of based on normal distribution. And it says if the variables have normal distribution, then the simple kind of statistical method will be used to find the outlier. And then, for example, if you have two input variables that are both normal, then the feature space forms a multi-dimensional normal distribution, and the knowledge of this distribution will tell us which observation is falling outside of this distribution, falling outside of the other distribution. And what it does, it will like shape a kind of oval, you call that, yeah, ellipsoid in another word. And then whatever observation or points that are outside of this oval, then they are going to consider as outlier. I mean, in simplest word, when observations fall outside of the overall pattern, right? And then the other method is local outlier factor, which is the simplest approach to identify outlier. And that approach is choosing the distance between neighbors, between observations, and this is based on the idea of nearest neighbors. And if the observations are not close to each other, they are considered, they are not in a neighborhood, for example, they are considered as outlier. And then the last one is one class CVM. This one actually use the binarized value. It will binarize value to 0, 1, 0, 1, and then it will classify them as kind of two groups. And then when they are when any observation falls outside of these groups, then they are considered as outlier. Okay, so I'm going to start with a minimum covariance determinant, because last time we talked about the first one, isolation forest. Okay, so what we are going to do, we are going to, first of all, let's go back to this one and get. So what we are going to do first, we are going to create the training data set, right? And then model the data set, and then create y-hat. So I'm going to copy this all here and run this. We have it. Bring the rest of that. So because we want to see what is the MAE for the original data set. Should be 49.7. Good. And then we are going to import a package. So now we don't need isolation forest, right? We are going to import covariance from sklearn. We are going to import covariance and we are going to call this EE dot elliptic envelope and then contamination. Oh, I noticed I never talked about contamination. Okay, so what is the contamination, which is one of the most important hyperparameter in these models? So this argument uses to help estimate the number of outliers in the data set. This is a value between 0.1 and 0.5, and by default it's set to 0.1. So if I change this to 0.01, for example, let's see what happens. If I change this to 0.01. Okay, so we're going to change this to 0.01. And then y hat, actually let's go back and change this to 0.01. So let's run the whole thing in the previous node, run this, and then, well, the number of outliers, this is important. Look at this, the number of number of data that remained in the data set is 12. So let's increase this to 4, and now 448 data set remained for us. And then let's increase to 5. We will have more data set. Well, I never tried more than that. So of course it says between 0 to 5, but why can't I change it? Oh, well, contamination 1. Now we are talking. This is the correct. So I don't know why the argument says between 0 to 1. Okay, so that will reduce the number of outliers in the data set we have. Let's make it 0.99. So I will go back to the what is that package and study this more to see what exactly the 99% is. That like maybe the confidence interval? It seems a confidence interval. So just 1% of data is going to be eliminated. And if this is true, I mean, it seems it's like that. Okay, so let's go back to this and let's change this to 98, for example. Well, still we haven't write down y hat. Okay, so our y hat is equal to, now we want to fit predict using the independent training set. And now we are going to use mask and y hat. Well, you know, to save time, I'm going to go back to this one from this one. I'm going to copy everything, bring it here, and the y hat is going to be this. I think everything else is correct. So let's see what happens. Okay, so now using this method and performing all what we have done using the other method, isolation, forest, the MAE, which is mean absolute error, is decreasing. It's not that, you know, good in compared to the previous or a whole data set, but still it's much better. Let me go back to that data set and change this to 8 to see what happens if I change the contamination to 98. So in this case, the using isolation forest, the MAE of reduced data set is not better than the original data set. They are almost identical. But here it has improved, means the MAE is smaller, even though the effect of removing outlier is not good. Okay, so I'm going to copy all of this, paste it here. And the other method that I'm going to use, did I write down what is the method here? So this method is covariance. Let me covariance determination. And then now this new method that is local outlier. So what I'm going to change here, first of all, I have to import the method that I'm going to use for outlier. So the method is neighbors local neighbors dot local outlier factor. So this is a method I'm going to use, and I hope it's correct. Let me see. No, it's not correct. Neighbors, okay, I have to. So what I'm going to do, I'm going to extract local outlier. Good. Okay, so what I did, I extracted local outlier factor, which is for local outlier factor method, from sklearn neighbor, right? And then we don't need ensemble anymore, do we? I don't think so. Okay, so what I'm going to do, so up to this part, we are just trying to get the original MAE. And from here, let's call this LOF, local factor, right? And then this is not covariance anymore, right? So what is going to be? It's going to be what I have extracted from the package sklearn neighbors, right? And then I'm going to bring it here. Now it should work. Okay, so what I did, I changed this method and I changed the method that I'm extracting the fit predict, and then I'm going to run this. Well, there is something wrong here. LOF. It says contamination must be in. Oh, okay. So let's make it 5. Let's see. The model didn't improve. So definitely, actually, you know what? This is a participation point for you. Look into this, because I have to look into this too. So what is the boundary? Because previously I realized the boundary is 0.0 to 0.5. But obviously for some of this method, I can increase the boundary and nothing happens, right? But for local factor, obviously when I change the boundary, something happens. So the boundary for local outlier factor must be between 0 to 0.5. Okay, so this is the participation point for you. You should study this more, look into this, and write down a paragraph about contamination and what is the boundary and how this is going to affect on 4 different methods that we talked about: isolation forest and covariance, and what is this one? Local outlier factor, and the next one that I'm going to talk about. Okay, explain that to me as a participation point. Okay, so let's see what happens. Here, the MAE increased, it didn't improve the data set. And then how many point has been removed? Almost 1,000 like something, because the original data set has 1,599 rows, and then now this new data set that is reduced and the outlier are removed has just 559 rows, right? Okay, so the other method, let's copy all of these and then paste them here. And then this new method is SVM. One class, SVM. Okay, so what we need for this one, I don't need this one anymore, right? So all of them, do you see that? All of them from sklearn package. So SVM. Actually, for classification also, I'm going to use some of these packages, some of these methods also. Kind of will be a little bit different, but will be kind of same method. I'm going to use the same method like SVM for the classification. Okay, this one should be capital, remember. Okay, so let's go here. Now we don't have a lower F. I'm going to change this to SVM. And what else? It's going to be 1. Actually, it's just here. I'm going to copy the whole thing from here and paste it here, and instead of LOF I'm going to write down SVM. Okay, see what happens here. I'm going to run this and we get error, unexpected error contamination. So what happens here? Oh, for the SVM, really? So for SVM we don't have contamination. So the argument, I think this should be correct. Let's see. Yeah. So for SVM, remember, for SVM, the argument is not contamination. It is NU. Okay, so how the it didn't even improve, right? We have 561. So for your project, I'm going to give you a data set that you can definitely see an improvement by removing outlier, and then the outlier will be more kind of the number of outliers that you are going to remove from the data set will be very more reasonable. Okay, so this is all for the outlier and kind of cleaning the data set if we are dealing with a data set that has high dimensional. And next time we are going to talk about classification. Let me know if you have any question. Have a good day. Take care of yourself.